So, informally, resonance theory is a system that involves ways of thinking that can be broken down into two different groups. One, resonance R, which is an assumption that there is somehow some structure that is wholly consistent onto itself, and discord, delta. Mathematically, a discord is any statement not able to be resolved within the current resonance. This could be anything wrong with a set of statements. We also usually have an operator circle, which allows us to make structures that are connected, and these structures connect R's, deltas, and by maps, they connect R's and deltas to different statements involving R's and deltas and maps. So resonances are not vacuously true, but rely on established math. And in terms of trying to understand discord, I would reference you to Gödel. Gödel is a great starting place for thinking about discord. In a proof, every discretization, we really do introduce some amount of discord into the system. The same holds true for every single claim we make. So if we have some set of statements that makes a claim, then that claim is going to have some discord in it. But if all of our statements only involve R, then we kind of take all of the possible maps as true. This is the nature of the resonance operator O subscript R, to distinguish it from ones that might not have this feature. So using this operator in terms of, put another way, a commonality between resonances is a resonance. And if there is any statement that holds true for a resonances mixed with discords mapping these two statements, then that statement must hold true for all substitutions of R in those statements. And then we can go on to define continuous functions as functions that allow us to sort of pull away at discord in certain ways and reduce it to a singularity of some nature, like we could do in analysis when we take a delta and we make it real small, we bring it down to a point, that singularity, or we blow it up to the point where the exterior and the perimeter and whatnot, taking some set of dx's along that, some derivative on those, differential operator on those. So yeah, that's that. We have this strange thing we call res discord, and this is written R delta. Res discord is a combination of resonance and discord between or among the objects of study. So so the res discord between two things is sort of an assumed binding operation of those two things. So if I give you a res discord R delta, I have to answer the question, is R delta separable? Okay, so that's a separable R delta, and we have definitions for separable R deltas. Let's see what's next. And for instance, consider the polynomials undefined on the reals, but they're defined on the complex numbers. And these are complex numbers such that the I component is not 0, and b doesn't equal 0. Taken together, these form an R delta. And how do we go about discerning that R delta? And for that, we would need some relations involving the complex numbers and the numbers of the reals. That would be the way of trying to chase down that discord. And then we get a separable R and delta. So that's one good example of how to form a separation using mathematics of an R delta and combining R's and deltas. Yeah. Okay. Objects can have their own internal defined resonance structures. Discords and res discords defined by relations between its own structure and the above ideas applied to its internal structures based on some operations within the structure that are related to some, say, interaction that would be an operator O that forms some pure resonance by quantum entanglement, for example. And in terms of the category, we have another object called a resonance space. And a resonance space is a collection of R's and deltas that are related by the operation O, and they map to other resonance spaces. Essentially, it's a category of these objects, and that's a good way of thinking about them too. And probably the most important notion in resonance theory that involves how these operations interact with each other is the notions of chirality. Normally, we assume that there is some chirality. We assume symmetry. But in resonance theory, we start by assuming achirality. In other words, statements of the form R circle delta map to delta circle R. But that is an assumption of chirality, that statement. So we start from the assumption of achirality. And achirality can get pretty deep, because if I compose operations and I have chirality on those, I have achirality on those operations. If I compose operations and I have achirality on those operations, then that means that the way in which those operations can be applied doesn't matter in any case. So any deltas can be moved around, any R's can be moved around. And then we do have a chirality operator that is the map operation that has the bar line with the triangle. Okay, do that again. And so with that operation, when chirality is broken by that map, then we have a state where that direction is implied somehow. Okay, so and then we have the notion of the chirality, which is the level of a chirality. And so map chirality increases. So a map of chirality 1 and then a map of chirality 2, where a map of chirality 2 introduces a second chirality, or like a second bonding to statements of chirality. And that essentially is a sort of recursive way of thinking about it, where essentially, if you're seeking to prove chirality, where chirality is implied by operators, um, higher chirality operations essentially are operations that have brackets around them, um, or should I say operations that have brackets around them. The way that those higher chirality operators are interacted with lower chirality operators, those statements relate to you trying to trace down the discord based on giving statements that are uh, they lack chirality. We can create many definitions for different kinds of chiralities, and one of the things that's interesting is trying to show how these chiralities are related in even deeper accepted structures, and sort of a seeking of chirality by starting from a point of achirality and taking some decent assumptions where needed in terms of when things would have chirality broken, but remembering that even if two things are different, um, so if I have x circle x, um, there is no chirality. So even if they're different on both sides, then the operation wouldn't matter because circle assumes there's no chirality. So it's a little bit of a weird notion, but it's a cool way of thinking about it, and I really want to start with getting you familiar with the way that we have chirality um, sort of started from a place that assumes that things are the same, that they are resonant, essentially. And we would have, say, in terms of something we would call a harmony, if we had some map to functions involving the real numbers, such that they were entirely predictable in their future based on relations involving those two values. But those two values will have some delta in terms of they're absolutely able to be determined values in reality, because those values are always going to have some delta. And certain assumptions on how that delta shrinks, we can actually say that these values approach zero. And this can be defined using the notion of continuous our deltas that essentially remove our deltas from our category, or painfully enough even introduce deltas based on operations involving two deltas that allow those deltas to be combined in some way that causes them to grow. And it really matters what extrapolations we make on the state that send our delta to R or delta by what in quantum mechanics would be called decoherence. The question would be the overall projected delta at the end when there are no observers, such that delta goes to zero in terms of the notion of decoherence. So what is the overall harmony and repeated patterns that form a resonance in the end? Is our delta separable? Discord is forever going to be there in those statements for incalculable number of reasons. How can they be brought into resonance? And we have a definition of decoherence that relates to some R delta state that involves that essentially being a decohered R delta, and that R delta is inseparable. So the point I want to make is that decoherent states essentially lead to inseparable R deltas. They involve relations on R deltas that are inseparable in some way, and relations upon those by composing relations. So then we come to probably the most interesting topic in resonance theory, and that is black holes, at least right now. In my mind, it's probably one of the most exciting ones. So in terms of entanglement, we're assuming entanglement exists. So the thing that happens is we have an R circle delta that maps to some delta and some R delta, essentially. But by black hole radiation, we have R circle delta maps to R delta. So, yeah, black hole radiation, we have R circle delta maps to R delta. We don't know what the black hole radiation is. And R circle delta, but now we have R circle delta also equals R circle delta of the singularity circle R circle delta of the exterior of the black hole, where R circle delta and the exterior of the black hole maps to R delta. And so we don't know what happens to the information that comes out. So there's some discord on the exterior, some resonance at the singularity, such that we essentially have this notion possibly of there being a Friese pattern. And a Friese pattern essentially maps R circle R delta to R circle R delta. It essentially freezes those two together. It is a chirality with no meaning, or an achiral statement, once again. So, and then also in terms of black holes, now we have this way of it being aseparate and separate. It takes R delta to R circle delta, and it is aseparate because it takes maps, and it is aseparate because it takes maps to delta. And those maps are of the form R delta maps to R circle delta maps to delta. I know. And so I'm going to explain this a little. So we have R delta maps to R circle delta maps to delta, says that statement is entirely of discord. It's chirality, it's achirality, all that maps to delta. And so these statements only have one direction of flow. And so the point is that we have to try to approach things from both the chiral and achiral perspective in the end. And for that, we use groups as a bit of a wedge. We have this notion of chi, which actually stands for chirality in our case, but we use the Greek letter chi. And I believe normally chi would be represented by a matrix, and that matrix would involve statements that are chiral. They have symmetry on those matrices. So it would be a representation in representation theory. But how we fill that representation is in question again. And this is actually good. This shows us that we're tracking down deltas and we're shrinking deltas down by definitions. Wholly consistent definitions. And these wholly consistent things, they relate statements together in ways that can be very inconsistent, or in our language we would say it maps to a delta. We're still looking to try to figure out how we can track down that inconsistency, and that's, Gödel's issue too. And that's a beautiful thing. And that involves going from two perspectives in some cases. So you have, we could assume the excluded middle, for instance. So the idea is we're sort of ever building resonance. And this ever building resonance, we try to move to some ideal value called omega. And essentially from that state omega, what would happen is we could almost perfectly predict certain kinds of resonances that, because they're all resonant, they're all related resonantly within omega. And this brings up a very, very strange issue involving time. So what is true and what is good and what is good for you and what are goals and stuff like that are resonant states of you, yourself. And there's some inherent delta there based on so many factors. But the omega state asserts that we find those factors and we find where they don't go right. And then we map that back to omega, essentially building resonance structures based on this notion of resonance and discord, and tracking stuff down by, chasing down discord, as I like to call it. By chasing down discord. Okay, so that should do it for a while. I'm going to do more studying and yeah, that'll do it.